Hi guys, let's take a look at this question where we have charged spheres A and B and another charge D that are now arranged. So that means it comes from a different question, right? So in the previous question, they told us that we have charged A and B and they gave us these charges, -4 times 10 to the power of -6 and +3. All right, so let's just jot it down here, right? In this scenario, A is going to be a positive charge because it's on the positive axis, right? Positive side. So it's going to be +4 times 10 to the power of -6, and B is +3 times 10 to the power of -6. So just so you know, that's where I get it from, and that's why it's positive, because it's on the positive axis. It has now been rearranged, right? All right, they give us the distances and they also give us the net electrostatic force, which is 7.69 newtons. 7.5, is the charge on sphere D positive or negative? It has to be positive. Why? Because it's on the positive side of the axis. If you just draw a Cartesian plane, that is where D is, so it's going to be positive. 7.6, calculate the magnitude of the charge on sphere D. All right, guys, let me just show you this calculation. So, what do we have? We have the net force, which is 7.69. We can calculate the electrostatic force of A and B. Why? Because we have been given the charges. All right. Then what will we have as our unknown? The electric force between A and D. But what do they want? They want the charge of D. So then we can use that electrostatic force to get the charge of D. All right. Let me show you how we do it. So first, we are going to find the electrostatic force between A and B, or of A and B. So we're going to use our trusty little formula there of that one. Again, please write down your equation. You do get a mark for it. I know I repeat it so many times, but just trust me. So K is a constant, 9 times 10 to the power of 9. Our Q1 will be +4 times 10 to the power of -6. And Q2 will be B, which is +3 times 10 to the power of -6. And we're going to divide that by the distance between them, which is 0.2 meters. And we square that. And we jot that into the calculator, and we get 2.7. All right. Okay. It's not the final part of the question. Then, so now we have the net force, all right, and we have the electrostatic force experienced here. All right. So we have this, and we have the net force. All right. So, oh, sorry, guys. So, we can use Pythagoras because it is a right-angled triangle. So we just write down our Pythagoras formula, squared. One side squared plus the other side squared. They have given this to us as 7.69. So we can just jot that in, 7.69 squared. And we don't have this one, so that's our unknown. And we have just calculated AB to be 2.7. Sorry guys, I just had to rewrite that because something happened with the laptop. So we just write that down there, not a train smash. And we do our calculator magic. We square root it to get the electrostatic force between AD to be 7.2 newtons. All right. So now what do we have? We now have the electrostatic force, right, of A and D. So we can calculate the charge of D by using the exact same formula, right? So we can find it by using the exact same formula. Just write it down again. Not a train smash to write it down again. So 9 times 10 to the power of 9. Q1 will be A, which we now know is +4 times 10 to the power of -6. Q2 will be our sphere D, which is unknown. And the distance between them, it's on the graph, which is 0.15 squared. All right? And we've just calculated FAD to be 7.2 newtons. We do our math magic, and we get D alone, or the charge of D alone, to be 4,5 times 10 to the power of -6 coulomb. And that is the magnitude of sphere D. And that's it, guys. See ya.